Okay, so this is exam 3 walkthrough for Introduction to Chemistry, and this is Form A. Form B is similar, just a different ordering. Okay, what is the chemical formula for triphosphorus tetrasulfide? So tri means 3, tetra means 4, so this is going to be A, phosphorus 3, sulfur 4. Some subscripts and superscripts got messed up in the formatting here, but these should be subscripts, P little 3, S little 4. What is the mass of 2.10 times 10 to the 21st atoms of copper? So given that information, I write it on the left. I'm after grams of copper. And I remember that I have to always go through the mole. So I know I'm going to have to go atoms to mole. Use Avogadro's number. And then use the molar mass here, which for copper is 63.55 grams per mole. Okay, multiplying across the top, dividing by the bottom, my units should work out and leave me in grams. And the answer should be E. Number 3 is an empirical formula. We talked about the process for that. Any formula here, the numbers, like up here we had phosphorus 3, sulfur 4. The numbers are the ratio of moles of each element. So up here there was 3 moles of phosphorus for every 4 moles of sulfur, that ratio. Here we have 0.25 moles of phosphorus for 0.625 moles of yellow sulfur. So I want to simplify that. I'm going to divide both of these numbers by the lesser of the numbers. So 0.25 divided by 5 is 1 phosphorus. Then I'll take 0.625 and divide it by 0.25 for my sulfur. That becomes 2.5 sulfurs. And so for every 1 phosphorus, there's 2.5 sulfurs. So I have to look, where is that ratio? And it should be A. The ratio of phosphorus 2 to sulfur 5, that's a 2 to 5 ratio. Just like if I multiply both of these numbers by 2, 2 to 5 is the same ratio as 1 to 2.5. So that's the only one that fits here. The answer should be A. 4% hydrogen. Okay, percent hydrogen is going to be, how much is hydrogen divided by the whole thing. The whole thing I'm given in the problem. It's a percentage, so times 100. The numerator here has to be the amount of hydrogen. There's 21 hydrogens, each at 1.01 grams per mole. So solving that, I should get E, 6.991%. Number 5 is a balancing reaction problem. It should come out to be D. I'm going to need 4 nitrates on each side, which means I need a 2 out in front of hydrogen. That should be it balanced. Number 6, which of the following solid compounds is insoluble in water? You just go to the chart for that. You should be able to determine its barium sulfate. 7, the student prepares, so that's experimental or actual. They've calculated, so that's theoretical. 1.88. So actual over theoretical times 100. And so here that's 1.75 divided by 1.88 times 100. And that should give us D. 8, considering the limiting reactant. So I know I'm going to have to do 2 conversions here, starting with each of the given compounds. So I know I'm going to have to go from 25 grams of each of these, 25 grams of aluminum. I'm going to have to do 3 conversions here, determining the mass of manganese. So that's what I'm after, grams of manganese. I also have 25 grams of manganese 4 oxide, so MnO2. Then I'm going to have to go to grams of manganese, and then I'm going to compare these two numbers and pick the lower one. Okay, this all relies on the fact that I have written and balanced an equation, because these middle unit factors here are going to be ratios of the coefficients in my balanced reaction, these middle unit factors here. Okay, so I better write the balanced reaction here. Let's think about manganese 4 means it's manganese 4 plus. Oxide, that's oxygen, it's 2 minus. So you can either cross these over and come up with Mn2O4, or a simpler ratio is MnO2. This is the one I'm going to use, but the other one would work. Everything would just sort of be multiplied by 2 and work out okay. So if you use Mn2O4 in your balanced equation, it should be okay. The molar ratio will take care of counteracting that. I'm going to use MnO2, which we're told reacts with aluminum in a single replacement, meaning aluminum steals oxygen. And the formula for aluminum oxide is Al2O3. Okay, so there's my single replacement reaction. I need to balance it. Okay, so it looks like there need to be 2 in front of the aluminum compounds and a 3 in front of the manganese compounds. That should give us 6 oxygens on each side. 4 aluminum. Should be 3, 4, 2, 3, I believe. That looks balanced, and now I'm going to be able to use that in my middle unit factors here. So 25 grams of MnO2, I need to get into manganese, so I need to use the molar mass of MnO2, grams per 1 mole. That's going to be the molar mass of manganese, 54.94, plus the molar mass of oxygen times 2, 16. So oxygen is going to be then O2 will be 32, manganese will be 54.94, for a total of 86.94. If I did that right, grams per mole, manganese O2. How many moles of MnO2 are there in the balanced reaction? There's 3. So 3 moles of MnO2. I'm going to try to calculate manganese here. So how many moles of manganese are there? There's 3. And so those 3s will wash out. And then my last one is the molar mass of manganese, 54.94 grams of manganese per mole of manganese. I'm going to do the whole same thing for aluminum, 26.98 grams per mole of aluminum. There's 4 aluminums for every 3 manganese. And it's still 54.94 grams of manganese per mole of manganese. So for the top one, I get 15.8 grams. The bottom one, I get 38.2 grams. I picked the lesser of these two, so it's the top one, 15.8. The answer should be D. Number 9, what's the mass of insoluble silver bromide produced from 2.96 grams of iron bromide? So here, again, we have to balance the reaction, 3 and 3, and that looks balanced. And then given information here is 2.96 grams of FeBr3. And I'm trying to calculate grams of silver bromide. So this is just stoichiometry, not a limiting reactant. Given one thing, calculate the other. Molar mass of iron bromide, I'm told, is 295.55 grams per 1 mole of FeBr3. There's 1 mole of FeBr3 per 3 moles of silver bromide. And the molar mass of silver bromide I'm given for free. That's how I would set it up, and I should be able to then calculate produce from 2.96 grams of iron bromide. I should get 5.64 grams. That should be C. How many moles of argon gas contain 7.52 times 10 to the 22 atoms? So atoms to moles is 1 unit factor here, Avogadro's number. You just divide this by 6.02 times 10 to the 23rd atoms per mole. Okay, you should get D, 0.125. What's the term for a digit in front? Right, up here we used coefficients. Okay, coefficient is in front, so 11 should be D. 12, considering the limiting reactant, so another limiting reactant. This reaction is zinc and sulfur getting together to make zinc sulfide. Zinc is +2, sulfur is -2, so it's just that simple. There's no more balancing I need to do. And so it's just now about taking each of these given informations here. 0.75 grams of zinc. And I'm gonna go through this a little quicker because we've done a limiting reactant one. There's a 1-to-1 ratio in the balanced chemical equation. And 0.35 grams of sulfur is the other equation. Oh, this last be 97.46. I'm going to mass of zinc sulfide. The last thing here should be that molar mass of zinc sulfide. So I should get, now that these are all set up correctly, I think. Starting with the zincs, should get 1.12 grams of zinc sulfide. Starting with the sulfur, I get 1.06 grams of zinc sulfide. Pick the lower of these. So my answer here should be E. 13, solid to a gas. We talked about this with dry ice. It sublimes. So sublimation. Type of reaction in which 2 substances react to produce a single compound. So 2 things come together to produce or to make a product. C. So that looks like a combination. Here, what is the molar mass of nitroglycerin? I should be able to do these by now. So the molar mass of each of these elements times their number. So for carbon, for example, it's 12.01 grams per mole times 3, 36.03 grams per mole. And I do that for each element, right? And then add them all up at the end. Okay, when I do that, I should get B, 227.11. Just don't forget this 3 out here gets distributed to the 2 inside and to the 3. So we should have 3 nitrogens and 6 oxygens from this unit, and then another 3 oxygens for a total of 9 oxygens in this whole compound. 16, how many atoms have a mass of 58.93 grams? So that many grams of cobalt. Grams to atoms, I got to go through the mole. To go from grams to moles, I use the molar mass, so 58.93 grams per 1 mole. And then to get to atoms, I use Avogadro's. And there's that many atoms per 1 mole. And I orient them like this so that the moles cancel. Okay, so my answer here should be E. Stoichiometry problem in number 17. Okay, having to balance this should be 2, 6, 2, 3. And then starting with the given information of aluminum. I know I'm going to have these 3 unit factors again. I'm trying to calculate the mass of hydrogen gas, so I'm going to grams of hydrogen gas. Oh, I left out a unit factor here. The molar mass of hydrogen is 2.02 grams per 1 mole for hydrogen gas, 1.01 for each atom. There's 2 atoms, so 2.7 divided by 26.98. Times 3 times 2.02 divided by 2 for 17. What do I get here? Let me, calculator's fritzing out. So 2.7 divided by 26. Okay, I get a 0.303 grams. 18, what are the products of single replacement? So you test and see, does silver come before cadmium, or what happens I guess, does cadmium come before silver in the activity series? If it does, then it'll react and we'll replace the silver. Okay, indeed it does. It should be B here because cadmium is going to come in and get with NO3. And the silver is going to get kicked out. But cadmium is one of those ions that is always +2. NO3 is -1. Okay, so that's why this crossed over to give me the 2. Outside here. So the answer should be B. 19 is a balancing one. I should get D6 after these are all accounted for. 2, 3, 1, 6. 20 is a limiting reactant. Here I give you the reaction already balanced. So you start with what's given here, 75 grams of iron oxide. Divide by its molar mass. Use the molar ratio. What is the mass of iron produced? So I'm going to the mass of iron here at the end. Iron is 55.85 grams per mole. The other thing I'm given here is magnesium metal. So 25 grams of magnesium, where magnesium weighs 24.31 grams per 1 mole. Just still a 1-to-1 ratio here of magnesium to iron. The last unit factor is the same here in the top and bottom equations. I get 58.3 made from iron oxide. I get 57.4 grams of iron made from magnesium. So I'm going to pick the lesser of those numbers. 20 should be B. And that's the end.